All right, questions 45 through 47 refer to galvanic cells made from different combinations of the three half cells described below. So we have half cell 1, half cell 2, and half cell 3. And then looking at these, it seems like, right, it seems like the galvanic cell X has the aluminum being oxidized, copper being reduced, and then the Y has aluminum being oxidized, iron being reduced, and then Z's got iron being oxidized, so that's basically Y flipped, and then copper being reduced, that's basically the same as X. So basically that galvanic cell Z is a combination of both X and Y, except X you keep it as is, copper being oxidized, copper being reduced, and you flip the Y and turn it into a version where, you know, the iron is not being reduced, it's actually being oxidized. Okay, so whatever. So 45, what is the standard cell potential of galvanic cell Z? What I just said, right? We keep the X as is, so it's just still 2.00, but the Y, we actually flip it, so that'll be negative 1.22, so you put them together, that'll be add them together, what I mean is 0.78, which is going to be answer choice B. Now, I want everybody to make sure to not forget that in electrochemistry, just because you have these coefficients, so for example, some people might say, oh, Stephen, if you take a look, well, if you have the iron as compared to 3 iron right here, like wouldn't you have to multiply this thing by 3 to kind of balance it out? Well, I understand, but whether you multiply by 3 or divide by 3, whatever the hell you want to do, just because you do something with the coefficients, it does absolutely nothing to your E naught cell value in terms of voltage. So remember that, please, right? It doesn't do anything to the actual voltage value.